So, today's exam from Module 3, Chapter 4 and 5, Question 1 is talking about finding the divisibility. This is the divisibility test for numbers 2 through 11. Now, these are the rules that we have. If you want, you can take your time, pause this video, you can go read through the rules. But I'm going to go ahead, jump into the question, okay? So, question 1. We have 6 different numbers: 684, 2064, and we have 51,051, we have 644,490, and we have 2,676,740, and then 50,250,528. Now, all we want to do is just find out if these 6 numbers are divisible by 2 through 11. Now, as you can see on the left-hand side, I wrote divisible by, and then I have 4 numbers on this first part, which is 2, 3, 4, and 5. And I show you and tell you how they are divisible by each number, okay? Now, we'll be flipping back and forth between the rules and the numbers, okay? Now, for number 2, don't forget that a number is divisible by 2 if and only if it is an even number, which even numbers end in 0, 2, 4, 6, and 8. So, as you can see for number 2, we have 684. It ends in a 4, so yes, this is divisible by 2. And as you can see, there's only one number that has odd, which is a 1. This one is not divisible by 2. I'm not going to spend a lot of time on that because that one is so easy. Now for number 3, I wrote down here on the side just like a little hint, so we won't always have to go back. The sum of the numbers are divisible by 3. And by sum, I just mean that each individual number, as in you have 684, it'll be 6 plus 8 plus 4. And then the sum of that has to be divisible by 3. That's it. And as you can see, I went down through here adding all the numbers together. I wrote what each number equaled, and then I divided each of them by 3 right here, as you can see. And I wrote either yes or no. So all these are divisible by 3 except for this one down here, which is 2,676,740. It's the only one that's not divisible by 3 because all the numbers added together will give you 32. And as we all know, 32 is not divisible by 3. Now if you come down here to 4, the last 2 digits have to be divisible by 4, okay? So if you come over here, you can see 84. I just grab the last 2 digits and I divide each of them by 4, and 2 of them are not, as you can see right here. You have 51 divided by 4, which 51 is an odd number, so it can't be divisible by 4 anyway. And then you have 90 divided by 4, gives you 22 and a half. It does not give you a whole number, so it is not divisible by 4. All these others are divisible by 4, as you can tell. 84 divided by 4 equals 41. Oh, sorry. I know that's not 41. It should be 21. That's what it should be. That is my fault. 84 divided by 4 should be 21, not 41. But the next one, 2064, 64 divided by 4 equals 31. That one's divisible by 4. Now, we're going to come down here to number 5. That's going to be quick. Number 5, the last digit has to end in a 0 or a 5. As you can see over here, that little bar is in the way right now. There we go. Okay, so there are 2 numbers that have the last digit 0, and none of them have a last digit 5. So only 2 of these numbers will be divisible by 5. As you can tell, you can look and see for yourself. Now let's move on to the next one. Keep this thing rolling. Now for number 6, follows back to rules 2 and 3, okay? Number 2, saying that it has to be an even number. Number 3, saying that all the numbers together have to be divisible by 3. And what I did for this one, I kind of just cheated a little bit. Since I already had 2 and 3 done, you can come over here and you can find which numbers 1 and 2 are divisible by 2. Then you come down to 3, find which numbers are divisible by 3. And as you can tell, the numbers that are the same, I wrote over here, I wrote divisible by 2 and 3. And then if it's not divisible by 2, I wrote not 2. If it's not divisible by 3, I wrote not 3. Okay? So we have the first two numbers, and then we have the fourth number, and the last number are divisible by 2 and 3. Now for number 7 is definitely more complicated, but over here in my rules, I just kind of simplified it for you. All you have to do is cross out the last digit, and then you want to double the last digit and subtract it from the remaining digits after you cross out the last one, okay? And I will just show you probably like 1 or 2, and then the process will just repeat until you get to the smallest number that you can, and then you'll just see if that one's divisible by 7. That's it, okay? So let's just look at the first two real quick. We have 684. 684, what we're going to do, we cross out the 4, boom. And you have 68 left. You want to double the 4, 8, 68 minus 8 equals 60. Now, as we already know, 60 is not divisible by 7, so that's obviously a no. Now, if you want to come back to the next one, 2064. We want to cross out the 4, it'll leave us 206, double the 4, it'll leave us 8, subtract the 8 from 206, it'll leave us with 198. Now we want to start the process over again. Cross out the 8, leaves us with 19, double the 8, leaves us with 16, so we have 19 minus 16 equals 3. 3 is not divisible by 7. Now let's see, let's find one that is divisible by 7. Let me go over to the other side. Let's see. I don't see any of these right away being divisible by 7. Let me go back through here and look real quick. And also, if you want, you can just take your time and go through all these numbers yourself. Okay, here we go. We want to come up here, and then we want to come down to the one at the bottom of the screen, right here where the mouse is. 2,676,740, okay? Where it has 0, if you subtract anything by 0, it'll automatically be that number. So I wrote skip because of 0, because there's honestly no reason to try to do that because nothing's going to change. So you simply just taking out the 0, and then you want to start out with 267,674. So then I just went ahead, crossed out the 4, and then move the 4 down. We're going to double it, leaves us with 26,767 minus 8, and that'll leave us with 26,759. Then we want to come over here. The process will continue, and it continues. As you can see, I wrote an arrow showing what comes next. And don't forget, you have to take away the number, bring it down, double it. And then the remaining numbers, you'll subtract that from those. And then at the very end, you get 21. 21 divided by 7 equals 3. So 21 is divisible by 3. So that means this whole big number right here is divisible by 7. Sorry, I meant 7. It equals 3, which is a whole number. So that means 7 goes into 21 evenly 3 times. So this whole number is divisible by 7. Now we're going to move down to 8. The rule for 8, let's go back and look at it. Numbers formed by the last 3 digits should be divisible by 8. Now this one, since the last 3 numbers, I went ahead and just use a calculator just to run it out real quick. And as you can see, there's only 1 right here. You have 1. Then you have 2, which 480 is divisible by 8. And then you have this one, the very last one, which is, yes, divisible by 8, okay? I just wrote them out, just throw in my calculator to find the answer. A lot of them I got decimals for, or decimal or a fraction, however you want to phrase that. Whichever way you want to phrase that, totally fine, okay? All right. Number 9. Number 9 is the sum of the individual, just like 3. Sum of each individual number has to be divisible by 9. So I came down here and then I added all of them up. You get for the first one 18, and then you have 12, 12, and you have 33, 32, 27. So as you know, multiples of 9, you have 9, 18, 27, 36, 45, all those. So any number that is under that category will be divisible by 9. And as you can see, added them all up, gave you the answer. 18 and 27 are the only ones divisible by 9. So only two numbers are divisible by 9. Now 10 is really quick. Just remember, if it's divisible by 10, then the last digit will be 80. Now, I know you probably can't see the very bottom because the bar is in the way. And I'm sorry, I don't know how to move the bar. But the numbers all the same for all of these, okay? We just want to know if it's divisible by 10. And luckily, it's 10 because you can see which ones end in 0. Only two numbers end in 0. As you can see on the one number 9, they're the same numbers, two end in 0. So then the two with ending in 0 will be divisible by 10. Last part to number 1 is 11, okay? Number 11, it's kind of like number 7. Subtract the last digit from remaining numbers, and then the answer should be divisible by 11, and then you'll repeat the process again. And then as you can come down here, you can see it's just like 7. I don't want to go back and do the same thing. So I just threw it in my calculator. And I told you that most of them were no because I threw them in my calculator. The ones that were yes, I just showed you what I put in my calculator. But remember, the process is the same for number 7. So I didn't feel there was really a reason to go back over that one because we've already gone over how to do number 7. Let's see, we're going to move on to number 2, okay? Number 2, we are just simply going to use process of 9 to check our work, okay? Process of 9 is simply on the first part. If you look at the worksheet that you have, you will see 416 plus 7,490 plus 69,844 equals 100 equals 112,790. Now all you do is you can see I broke each number down. Okay, you're going to add each number up, and then however many it's over 9, you're going to put a remainder. So for 416, I just add each number up, get 11, and then it's 2 over 9, so you put remainder 2. And you do that for each one, okay? And then for the numbers on the left of the equal sign, you're going to put that remainder at the very bottom, which the remainders added up will be remainder of 8. Now, the number on the right, I put that off separate because it really should be separate. And you want the remainder for both numbers to be the same, okay? So I added the numbers from 112,790, and you got 20, remainder 2, because 18 is divisible by 9, so I have a remainder of 2. And as you can see, the remainders are the same, and I wrote out the correct answer for this problem. And this process of 9s to check your answer is simply just to see if they have it right. Now you can use a calculator, but this is for if you don't have a calculator, okay? Simply just if you don't have the calculator, that's it. Now all of these, none of these are right. So you're literally going to come through here, do the same process over and over again. As you can see, as I showed down here, I showed you have 8,550. I added each number together. I got 18, remainder 0. And then I added the next ones up. There's 4 different numbers on the left of the equal sign. Remainder of 16, not a remainder, yes, a remainder of 16 all added up. And then 16 is 7 more than 9. So I have a remainder of 7 left. And then on the other side of the equal sign, I have 23,892 equals, all those numbers added up equals 24, remainder 6 because it's 6 more than 18, which remainder of 7, remainder of 6, they're close, but they're not the same. So this problem is wrong, and I wrote the correct answer down here for you. Now we're going to move on to number 3. Number 3 is simply we're going to use rods, just trying to find out, they're going to be multiplied, okay? So using rods 1 through 10, each rod measures its number in centimeters. Rod, for example, rod 2 equals 2 centimeters. Given a number, I will show which rods equal the same number. And it's literally greatest common factor, okay? But on this one, I believe it said the greatest divisor or divisor, whatever number, like we'll divide into it. Let's see, number 3 says the colored rods shown here are 1 centimeter square in length, 1 through 10 centimeters. We say that a rod measures another rod if a number of the first rod placed into the same lengths, okay? So, rod 9, what numbers can be multiplied to equal 9? And the only ones that I know of are 1, 3, and 9. 1 times 9, 3 times 3. That's it, okay? So, then we come down to 6. 6 is also pretty simple. 1 times 6, 2 times 3. So then you have the numbers 1, 2, 3, and 6. And then, like I said, the greatest common divisor between 9 and 6 is 3. They both have 3 in common, and that's the greatest number that they have in common. So the greatest divisor will be 3. Now for part D, where rods are equal 18 with rod 10 plus 8. Okay, so I have 1 times 10 will give you 10 because that's rod 10. And then you have 2 times 5, which will also give you 10. That's for rod 10. And then you have 1 times 8, which will equal 8, and then 2 times 4. That'll give you 8. And then which rods will equal measure of 18. So I did that 1 times 18, 2 times 9, 3 times 6. So you have 1, 2, 3, 6, 9, and 18. And then for the last part, the numbers used to equal the big rod, the largest number that is shared, the number will be the greatest divisor. It can be divided by or into both numbers, okay? And it's, for me, I look at it as greatest common factor just because that's easier for me to remember than greatest divisor. They're pretty much the same thing, just said differently. Let's move on to number 4. This is using least common multiple, okay? This one's actually pretty fun. It looks tough, but once you get used to it, it's simple, fun, and fast. Using the factoring method, I'll show you how to find least common multiples of 3 numbers. I will use prime numbers to find the prime power form. That's what the scary part is. You got to find the prime power form, which it's honestly not that bad, as you'll find out. So generally what I like to do, I like to start out with the smallest prime that can be divided into the first number, okay? Now, it doesn't really matter if you use the first number or the other numbers, as you'll see later on. So the smallest prime number for 48 is 2. 2 is the smallest prime, that, and it also has to be able to be divided, so that way you can get a small number. So if I used 1, it would still be 48. So there's no point in using 1. So let's see. Sorry, my screen sharing just went out because my window's closed. But I can still explain this to you real quick. Let's see. I can go over here and I can find right where I was at. Just make sure to always have like a backup ready. Let's see, I believe it was somewhere around here. Right here. Okay, these come multiple, we were right here. So for 48, I just drew out like a little chart, kind of like tic-tac-toe, but an extended form. That's it, okay? So an extended form of tic-tac-toe. Let's see, I've got to go to share. All right, now you should be able to see what I'm talking about, okay? So kind of like tic-tac-toe. I wrote, this is what I did first, second, third, kind of like my steps and whatnot. So you write the 3 numbers that you're going to use on the top row, okay? And then you want to leave the far left side blank. I just kind of just jumped right into it on my paper, and I started out using 2. So I wrote 2 on the far left side at the very top. And then with the 3 numbers, whichever numbers can be divided by 2, I do that. And then if it cannot be divided by 2, I just bring it straight down. That's it, okay? So 48 divided by 2 equals 24. 25 and 65 cannot be divided by 2. So then I want to keep using the 2 until I get the number in that column all the way down to its smallest, okay? So let's just jump all the way down to where it says 6. And then I can do 6 divided by 2, 3. Boom, right there, down. So now I have in that row 3, 25, and 65. And then I want to divide 25 and 65 by 5. And then on the very bottom, I have 3, 5, and 13, which 3, 5, and 13 are all prime numbers. Now the numbers on the far left and the very bottom, you will see, we're going to use those in our answer. You see 2 appear 4 times, okay? So we want to put 2 to the power of 4 because that's how many times we have the 2. Then we have 3 appear 1 time. And I just like to keep mine in numerical order. So I have 3 appear 1 time. So then I'll do 2 to the 4th times 3 to the 1, because we only have it 1 time. And then 5 appears twice. So I want to multiply that by 5 squared. And then 13 is only on the 1. I want to write 13 and do not forget the 1. I forgot it, but don't forget to put the 1 right over the top so it's understood that we only have 1. Now, if you come down a little bit with me, you'll see we have this one right here. This one has 4 numbers. It's no problem at all. Easy to work out, same steps. I still started with 40. I used a 2. That's the one that can be divided by 40, and it can also be divided by 12 and 44, okay? Divided into. So you just want to bring these numbers down after dividing all these by 2. And this one does not divide evenly into 2. So I just want to bring this one straight down. And I'm going to use that 2 as far as I can get it, okay? So I have 40, 6, 22, and then I just kept the 363. Now, I want to do 2 again. So I have, boom, bring that down to 10, 3, 11, 362, okay? Now, I'm right here, okay? Now, I could do 2 again, but I decided not to. I could have done 2, but I just went ahead and jumped to 5. So I have 5 right here, and I bring it down. Boom. I have my 2, and that one's a prime, and then I bring the other ones down because they cannot be divided by 2. Now, I know that 363 can be divided by 3. So I'm going to do that, and also 3 can be divided by 3, which will give me a 1. And then the other ones can't, so I'm just going to bring those down. As you can see, 363 divided by 3 was 121. And then I know that 11 squared is 121, so that goes into 11. Bring all these numbers down. 11 times 11 divided by 11 equals 1. Boom, bring that down. And then if there's a 1 on the bottom or the far left side, we're not going to worry about that, okay? We're just going to kind of skip that and not write it down at all. So you have 2 appear 3 times, so 2 to the 3rd times 3 to the 1 times 5 to the 1, and then 11 appears twice, so we're putting 11 squared, okay? Remember, 1s are not included. Now on the right side over here, you can kind of see what I did after I've explained these other ones. Just look through here, you can see the pattern, and then my answer down here is 2 to the 4th, 3 to the 1, 5 to the 3rd, 7 to the 1, and 11 to the 1, okay? Now, let's move down to number 5. Number 5, we have 2 gears here, okay? 2 gears. One is has 48 teeth. The other has 84 teeth. Now, all we want to do here is we want to be able to find out how many more times does the smaller gear need to turn to get back to where it started on gear that has 48 teeth, okay? Now we want to know how many more times. Now, as you can see in my answer, I have 7 revolutions. Like, I use the tree, okay? You can use another method, but for me, the tree is the easiest one to use. And if you know how to use Excel, you can go to Excel and it'll do this for you. But, so this is how many rotations, turns, rotations, revolutions, whichever you want to use, okay? So I did 1 through 10 for the smaller one, 1 through 5 for the big one. And you just want to find whichever number is the same, which the first number is the same, 336 are the same for both these, okay? The big one turns 4 revolutions. The small one, which we wanted to know, turns 7 revolutions. So now we need to find the difference because we want to know how many more times does the smaller one need to turn than the bigger one, okay? So how many more turns? I did 7 minus 3, which I should have done 7 minus 4. I'm so sorry. So sorry about this. But 7 minus 4, don't feel free to correct me. And 7 minus 4 equals 3, okay? So the smaller gear will make 3 more turns, not 4. 3 more turns in the bigger gear. And this one's just really simple to see and everything. It's not hard at all. Now, down to number 6, we want to find the perfect square. Now, I went and I looked up different information on perfect squares, and what I found is something really cool, that all the corners will be the even numbers. Like if they're all in order, as in like 0 to 9, you have 0, you have, my bad, 1 to 9. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Numbers like that. And you can only have 9 numbers because it's a 3-sided square, 3 by 3. 3 times 3 equals 9, okay? But if all the numbers are in order, all the even numbers will be on the corners. And then the middle number the number that'll be right in the middle will be the median number of the set of numbers, as in up here, the median. The median of all of these will be the middle number, which right here, -3, is the median. And that'll help us out later on. But there is also a trick that you can use to find the magic number, which the magic number simply means this row right here, this row right here, this column, that row, and even if you go diagonal, it'll all equal the same number, okay? So if you add the numbers up that you're going to use, and then divide the sum by the number of one side, which one side is 3 right here, as you can see, 3-sided figure. If you divide it by that, it'll give you a magic number. So adding all these numbers up, I get -27. -27 divided by 3 equals -9. -9 is our magic number. Now, if you remember what I said earlier, this will make it a lot easier. And I noticed this after I worked all this, okay? Remember, I said the median number will be right in the middle, okay? So it's -3. -3 is right in the middle, bam. And they give us this number right here, 1. So if you do 1 plus -3, that'll give you 1 plus -3 will give you -2. And you want to get -9. So -2 plus, obviously, -7, or -2 minus 7 equals 9. So then -7 will be right here, as you can see right there. And then since we already have the middle number right here, which is -3, and a 0, -3 plus -6, or -3 minus 6 will give us 9. So you want to plug in the -6 right there. And then after that, you're literally just plugging in different numbers, and this makes it so fast for you, okay? So fast that you'll be able to fill this out in no time. Just remember these cool little hints about even numbers being on the outside and the median number being in the very middle. And then this is how you find the magic number, and then it all will just fall right into place. Thank you very much for listening. I am Mr. Scott, and thank you for sharing your time with me.